Okay, so in this video I'm going to show you how to perform a two-sample t-test using SPSS. We have two groups, group 1 and group 2. This variable that we're going to compare is sleep, and the first 10 observations correspond to group 1 and the second 10 observations correspond to group 2. In total I have 20 observations. So sample 1 would be the first 10 observations and sample 2 would be the second 10 observations, and the objective is to compare the average sleep time, may it be an increase or decrease. On average, how much change did a student have in their sleep patterns in group 1, and in a similar way we want to compare it to the average time, sleep time, increase or decrease, average, for group 2. So we're going to compare the average of the first 10 observations, which would correspond to group 1, with the second 10 observations, which would correspond to group 2. So you can't compare the two samples unless you have a grouping variable in SPSS. That is a problem with SPSS. In addition, SPSS can only do a two-tailed test, and by default you will have a two-tailed test. So how do we perform this? First, we select both the variables, Control-click would do the deed in most cases. So after selecting both variables, go to Analyze and scroll down to Compare Means. So here we shouldn't do one sample t-test because we have two samples, and in this particular case we are assuming that the samples are independent. So click Independent Sample t-test, and automatically recognizes that the test variable is sleep because I actually used it previously, but you'd have to select the sleep variable, which is the test variable, and the grouping variable, for instance, it would be over here on the left hand side, and you'd have to move it to the right hand side. So let me show it to you. So both variables, when you first start the data set, you'd have both variables on the left hand side over here, and we'd have to move it to the right hand side. So the test variable is sleep and the grouping variable is group. And right now you see two question marks over there because SPSS does not know what the two groups are. So we have to define the groups. So press define groups and say group 1 is 1 and group 2 is 2. Mind you, when I first started SPSS, or when you first started, you wouldn't see 1 and 2 here. You'd have to specify 1 and 2. Those are the two groups. You have to look at the labels for group 1 and labels for group 2, and you have to enter it over here and continue. And now the question mark disappears and the grouping variable is group, and the levels in which they are grouped are 1s and 2s. Now that's all you need, and you can go ahead and press OK, and that is the output. And this output has a lot of things. The average of the first group, the time, the change in time was about 0.75. We had 10 observations in sample 1. For group 2, which is the second sample, we had about 2.33, 10 students again, and the standard deviation for the first sample was 1.789 and the second was 2.002. Now there are two cases here. We can either assume that they are identical, that the variances are identical, or you cannot assume that the variances are identical. In the class, when we did the two-sample t-test, we assumed that the variances are identical. So we look at the top row. You can ignore this output, which is another test. It's called a Levene's test, which tests for equality of variances. We can forget about that. We don't need that. All we need is the output of a two-sample t-test, and we're looking at the top row. because we're assuming that the variances are identical. So the test statistic is 1.861. The degrees of freedom is n1 plus n2 minus 2 for an independent sample t-test, and here n1 and n2 are 10, so n1 plus n2 minus 2 is 18. The mean difference is minus 1.58, and the standard error, which is the denominator of the test statistic, is 0.8491. So right here you see something called sig two-tailed. Sig two-tailed stands for the p-value. It is nothing but the p-value that we had. Excuse me, I just pulled it out. So that is the final output. Now you can edit this output just by right-clicking and editing this, but I'm not going to do all that. For instance, you can click on that and increase the font size to 12, and it increases to 12. You could reduce it back to 9 if you want to. If you want to fancy it up a bit. So all I have to do is double click on the output that I see. But what is more important is to see that when you perform a two-sample t-test using SPSS, the test statistic is given to you, the degrees of freedom is given to you, which is easy to find anyways. The p-value is also provided, the numerator of the test statistic, the difference in means, and the difference in the standard error of the difference is also seen here. In addition to test results, you also get a confidence interval for the difference. So if you have a difference mu1 minus mu2, according to the samples that we have at hand, the difference mu1 minus mu2 would have a lower bound of minus 3.36 and an upper bound of 0.2039. So mu1 minus mu2 will lie between minus 3.36 and 0.2039, and we have 95% confidence in finding that interval. So that is how you perform a two-sample t-test using SPSS. To recap, you just have to press Analyze, go to Compare Means, go over to Independent Samples t-test, and select the test variable, grouping variable, and press OK, and you're done. You could also change the confidence level by changing options. Instead of 95%, if you select 90%, and hit continue and OK, you'll see this time we have 90% confidence level. But keep in mind, this confidence level is not going to affect our test results. The test results are independent of the confidence interval. The test conclusion depends on the confidence level that you set, but the test values, such as the test statistic, degrees of freedom, p-values, they're not dependent on the confidence level. And you could see that the interval here changed because I changed it from 95% to 90%. So that is how you find or perform a two-sample t-test for independent samples using SPSS. I hope you enjoyed the video. Thank you for watching.